Difference between derivative and antiderivative. So to understand what is the difference between derivative and an antiderivative, we should know what actually is the derivative and the antiderivative. So derivative is actually, we use a derivative when you have to find the slope of a function at a given point. Now, what is the slope actually? For instance, if this is my graph and on x and y axis, my graph is going somehow like this. So I can see this curve here. This is actually my slope. So we just work on the slope in this derivative thing. And we considered there are some points here as well. So we considered this slope as a point here. Whereas in antiderivative, or sometimes we call it as the integration as well, in integration, we use it to find the area under the curve of a function that is integrated. For instance, if this is my graph, and it's making a slope. We know it already that slope is actually is for the derivative, but here in case of integration, we work what is under that curve. So we have to work what is the area under that curve. So we have to work somehow here, and we consider it over the interval. So this is the difference between the derivative and the antiderivative. There is one more thing here, the symbols between both of them. For derivative, for instance, if I have a function f, and if I have to show the symbol that it's a derivative, then I'm going to write like this. I'm going to put a prime on it. Or I can also write it like this, d over dx. So if there's f is the function, I'm going to write like this. So this d over dx is actually the symbol of derivative as well as this prime. Whereas in integration or antiderivative, my symbol is integral, this sign, and I have a function here which will be in this bracket along with a dx. This dx means that with respect to x, it can be changed. For y it will be dy. So for instance, if I have to write an integration function, it will be 4 integral 4x square dx. So if I have to take integration of this one, I'm going to write it like this. Now let's see an example. We have a question here, which is function is given and it's f of x is equal to x square plus 2x minus 4. Now see how does this thing apply on our questions. So for this, first of all, I'm taking derivative of the same function, this function. So my question is f of x is equals to x square plus 2x minus 4. Because I'm taking derivative, so I'm going to put the derivative sign here. Either I'm going to write it like this, or I can also write like this, df over dx. Both mean same. Now, because I'm taking derivative, according to the property of derivative, if anything which is in the power, I have to write it with the variable. I have to put it down. Then I have to subtract 1 from that power. Similarly, with the other 2x thing, so it will be 2x. If there is nothing in the power, I mean, I will gonna put it 1 here, so I'm gonna subtract 1 from here, and the derivative of constant is 0. So if I solve it, it will be 2x to the power 1 plus 2x to the power 0 minus 0. So I know it very well that anything whose power is 0 is actually equals to 1. So my answer would be 2x plus 2. So this is my derivative. Now let's see with the same question, what happens if I take the integral or the antiderivative here. So this is my function f of x equals x square plus 2x minus 4. Now I'm taking the antiderivative of this one. So I'm going to write it like either like this, or I'm going to put it the sign of integral. It's up to me. I'm preferring here this function because the given equation is in the function form. So in an antiderivative, what I'm going to do, I'm going to add 1 in the power and I have to divide it with that thing. Again, I'm going to add 1 in the power. There's nothing, I'm assuming it's 1. And I'm going to divide it with that power. And if I have some variable here or any constant number here, not the variable, only if I have a constant number here, and if I have to take the antiderivative of that constant number, that thing will get a variable with it. In case of derivative, my constant is equal to 0. But in case of antiderivative, I just place a variable with that constant. So if I solve it further, it will be x to the power 3 over 3 plus 2x square over 2 minus 4x, and c is for the constant and it's mandatory. We have to place it in antiderivative. Now if I solve it further, I will get x cube over 3 x square minus 4x plus c. This is how I solve my question in an antiderivative. So let's see another example. This time my function is x square plus 2x plus 8. If I'm going to take the antiderivative of this function, it will be 2x to the power 1 plus 2. So the power is actually decreasing here in derivative. While in antiderivative, if I'm going to take the antiderivative of this one, I'm going to write x to the cube plus over 3 plus 2x square over 2 plus 8x plus c. So you can see my powers are actually increasing here. So I'm going to write it in a more simplified form. So it will be written like this. So the difference here, you can see it easily that my power is decreasing in derivative, but it's increasing in antiderivative. So this is for now. For more videos, just subscribe my channel.